Okay. Welcome everybody. Welcome Benny. We are here at the Plugfest. This is the almost final session we are doing today. After this one, only one left. This crowd. Everybody wave at Benny. And we have a lot of people joining us online. Benny is online too, as you may see. And he will be presenting about OCPP and error codes. Benny, can you please introduce yourself and present your minimum required error codes?
Thanks, Martin. Am I audible to everyone? Good. Okay. Welcome and good afternoon, good morning, good evening, wherever you're at. Hope you've had a good Plugfest so far. Apologize for the late session. I'm sure you all are ready to go home and catch some rest after the testing for the day. Remind me again, this is today and tomorrow, right? The Plugfest in your time? Okay, awesome. My name is Benny Varghese. I'm a research engineer at the Idaho National Laboratory in the US. And today I'm going to present about some of our works that we've done with the ChargeX consortium. I will get into quick detail on what the consortium is about and also introduce the work we did, and we can discuss if you have any questions, how that is applicable to the European market, if any, and what are the next steps going forward. Again, during the presentation, at any time, if my voice is breaking up or if we're having audio issues, please raise your hand or let Martin know, and I can pause and repeat myself, and that's not a problem at all. So coming back to ChargeX, so the ChargeX consortium is a multi-lab consortium formed by or funded by the United States government, specifically the Joint Office of Energy and Transportation, which was recently established, given that transportation is starting to get electrified in the last couple of years, and also looking forward into the future. So the vision of the ChargeX consortium is to have, as stated on the slide, a reliable, frictionless charging experience for all. And the mission is to bring together EV charging industry members, national laboratories, consumer advocates, and other stakeholders to measure and significantly improve public charging reliability and usability within 24 months. And so this means it's June 2025. So the consortium kicked off in June 2023. This was one of our very first deliverables or work outputs, that is the development of the minimum required error codes. So put it simply, ChargeX, the goal is with different kinds of users, any user, any method of payment, authentication that they're using, any vehicle, any charger, that they should be able to charge the first time, on the first time, charge every time. So that's in a nutshell, that is the vision of ChargeX. So we have 3 different working groups within the ChargeX consortium to tackle these reliability challenges. It is a collaborative effort with industry involvement and the national labs working together to solve the biggest challenges that we have with EV charging reliability in the US. And so the error codes effort itself that we're going to talk about today is part of the diagnostics task force under working group 3. So working group 1, again, I won't get into too many details because we are short on time. I will share you the link, share the link for our ChargeX website, and we should have more details on each of these working groups and the issues and the different kind of issues we're going to tackle there. So a little background, most of you are familiar. Again, this is something that we've put together, a map of the different stakeholders in the ecosystem. We have everything from EV OEMs, EVs, EV users, EVSCs, EVSC manufacturers, CSMS or CPO, CSOs, EMSPs, and the hub or roaming platform. So those are different pieces. The idea was we're going to lay all these out, figure out which of these have certain standard modes of communication that are open to the market, and some others might be proprietary. For instance, EVs talking back to their OEMs might be different for different manufacturers. Similar for EVSEs, the EVSE manufacturer themselves might have a separate link to the EVSE, etc. And again, same with EV users, there is no standard method of operation, so to speak. Like different users might perform operations in a different order, may interpret instructions in a different order, etc. So looking at this entire ecosystem diagram, so to speak, we realized quickly that any errors that show up in this process have currently, the way they're communicated out is not necessarily a standard process. And what that means is two different EVSEs can say high temperature or emergency stop or any other different error, and that may not mean the same thing to either the EV or the CSO, and there is a bit of a mismatch on what these definitions are. Some of them have been standardized or given specific definitions in OCPP 1.6J. In the 2.0.1, it's gone more towards the device model, where you could, depending on your device and your subsystem, you can send out specific errors. So what the purpose of ChargeX here and the minimum error codes here, we started an effort at EBS 36 in Sacramento earlier this year. I think it was June. Got together some folks from industry who expressed interest, and we came together to define these error codes, a common set of definitions, so essentially speaking the same language between different EVSEs and the ecosystem in general. So the purpose here, as you can imagine, is we are able to simplify the troubleshooting and diagnostics, and thereby reducing the downtime. When we all have the same error code, meaning the same thing for different manufacturers, different EVSEs, EVs, and then that makes it a little easier to troubleshoot, diagnose issues, and then consequently reduce the downtime and make things easier from a reliability perspective. Coming to the scope, the minimum recommended set of error codes is what we're targeting. And this is limited to EVSE communications for this particular document. Again, this effort was started pretty not too long ago, a couple of months, I would say. So we are focused pretty much on this particular piece, where most of the errors that you'll see in the list that I show are EVSE specific, and they could be sent out either to the user via the HMI interface or to the back end via OCPP. And these are limited to error code definitions for now, not necessarily delivery mechanism. And also we did put together error code classification, which is we also have some responsibility classification and functional classifications. I will get into that briefly after I pull up the list. All right, so the list itself we have here. We've got connector lock failure, which is a failure to lock and unlock connector on the vehicle side. Ground failure, GFCI has been activated, and high temperature overcurrent failure, over voltage, under voltage, a weak signal, emergency stop, authorization timeout, invalid vehicle mode, cable check failure, pre-charge failure, no internet, pilot fault, power loss, EV contactor fault, EVSE contactor fault, cable temperature derate, cable temperature over temperature stop, and partial insertion, capacitance fault, resistance fault, proximity fault, connector voltage high, broken latch, and cut cable. So specific definitions for each of these are present in the PDF. I will share a link to the ChargeX website at the end of the slide. Feel free to note that down and can get into more details there. So some of these I have to say, especially the beginning ones, you will recognize these. These are familiar from the OCPP 1.6J, and a few others are from, as suggested by the EVgo's list of minimum required error codes as well. And the process for selection of these, I will touch on briefly, but we did put a list together, got together industry participants from the ChargeX consortium, got their feedback on what do you think about these, how important are these, or do you have the ability to do these right now, was one of the criteria. And the other one was, if you don't have the ability, do you still think it's important that we recommend this as a minimum required code? Again, this is not enforced in any way in the US at this point. This is a recommended list essentially for the EVSE operators that want to say, hey, we want to do this, we want to get to the high reliability that the customers expect from us. So we're going to adopt this to make diagnostics easier and provide a better customer experience. So coming to the responsibility classification, this was proposed to address some of the ambiguity surrounding the source of the errors. So when a certain error is transmitted either to the HMI or back to OCPP or to the vehicle even, now there is a hard time classifying whose responsibility this is. This is again a request that industry has put forward, asking, hey, if there is a third party that can tell us, look, this error means certain stakeholder is responsible for resolution, that make our life easier. So we put them into four basic categories right now. One is the EV user, the CSO, EVSE, and the EV. So just an example here, we've got I'll pull up a few. Let's say number 8, emergency stop. So we marked it as EV user and EVSE. So since the EV user could be the one pressing the e-stop, but at the same time, it could be due to poor instructions or poor markings on the EVSE. Like there have been cases where some users have thought that is the normal way to stop a charge session, which it is not, but then they end up pressing the e-stop, the button's depressed, and they cannot, the next person cannot charge on that. So could be an issue of mix of both. Again, for instance, number 13, no internet, this could be the CSO's responsibility for when they installed the internet device, or site selection, not adequately checking for connectivity issues in that area, and could also be something to do with the EVSE hardware as well. Again, the same goes for, so for the 26 different error codes, we have most classifications laid out, and most of them you would see have some component of EVSE to them. One other I would point out is with number 18 and 19. So this was initially when we started out this effort, we talked about this as cable over temperature as one error code, but with feedback from industry, I think there have been enough cases where the cable over temperature just results in a derated power delivery, so a lower power mode, and very few times you do have like an actual complete shutdown of the system. So we've decided that there's value in separating those two out, so we can actually identify recurring issues, or identify when you need to restart the system or send a truck out. The next one we have in the report is also a functional classification. Again, this is less for diagnostics itself, but to understand what functionality is indicated, what functionality is reduced when you see a certain error code. And this provides a way to prioritize troubleshooting. We have 5 categories here. We've got safety, security, maintenance, financial, and authorization. So again, we've got, for instance, a lot of these you would see are safety related, again, and that is on purpose to try and make sure that we are focusing this set is not comprehensive. This is meant to be a very bare bones starting set for a manufacturer that is trying to implement certain common error codes, so to speak. So again, details on all of these are present in the PDF as well. Feel free to ask questions now, or we can, or once you have taken a look at the PDF, you can send in your questions via email as well. Going to the selection criteria, we picked based on first we have the different stakeholders that were responsible, so that would be the responsibility classification, and we've got the functionalities that are being affected, resulting in our minimum set of error codes. And we actually started with a much larger set of close to about 50 to 55, I would say, different error codes, and then filtering it through these different functional requirements and the different stakeholder responsibilities. We ended up with this minimum required set of error codes that we're putting out as a recommended practice document that potentially could be adopted by different EVSE makers, CSOs, depending on how they would like to implement this. So to summarize, this effort was born out of a lack of standardization in error code definitions, and there was also a challenge with custom error codes where several manufacturers, several players were just putting in an other error without really giving too much detail, which resulted in delays in diagnostics and troubleshooting, or having to send out a truck every time there was a particular set of error codes that had to be, again, individually diagnosed without context for where the error is coming from and what the details are. And we talked about responsibility and functional classification and selection criteria, and also the list. So with this particular work, the idea is we are going to work with industry partners. We have a couple lined up right now to implement this set and demonstrate at the Testival event in November in Cleveland, Ohio, in the US. And so we are going to use that as a testing platform to see which of these error codes we can put in and successfully demonstrate. Again, with different equipment, there are different architectures, different topologies that the manufacturers are using, but at the same time, but the same error code should mean the same things across. So that how they implement it is not for us to decide, and we're not going to specify this should be from a particular component in your device model. This is more along the lines of, hey, if you have a certain error, this is the code you need to put out. And the other thing I'll mention is that you could use multiple sets for errors when you are dealing with something like this, but when you're using something from the ChargeX set, it is recommended to use a different vendor ID, so we know you are referring to a particular definition that is defined in the ChargeX document. So again, more details on that to follow. We are still working out on an implementation guideline, so we can send out example JSON packets. We'll show. All right, so we can send out the JSON packets. We can share suggested ways to implement that we're working on, and we are going to try and extend this beyond. Sorry. Is my presentation still in full screen?
No.
Oh.
No, it's still on the. Oh, yes, now it's on full screen.
All right, thank you. Sorry, something's happening here. Okay, yeah, and so we're gonna extend that beyond error codes communicated just by the EVSE. We're gonna probably extend this effort into 15118, possibly OCPI, OCPP, etc. as well. How these error codes are communicated between the different data silos that currently exist in the ecosystem. And also include troubleshooting codes, get into a comprehensive list of failure modes and how the related errors are resolved. So that was it, brief presentation. I was told to keep it to about 15 minutes, did go over just a bit, but feel free to ask some questions. I got a few more minutes to take questions here. And for more information, visit chargex.inl.gov. That is where you can find this particular report and any future publications and work products that are going to come out from the consortium, and just for details on the consortium as well. Thank you.
Okay, thank you. And can you hear me, Benny?
Yeah, I can, Martin.
Okay, let's see. Oh, crowd started filling up. So welcome everybody who joined us later in the session. Do you have any questions here before I go to the ones? Here we go. Please state your name.
Hi, Coach Neus, the Ekeval. I had a question. You said that the addition of D-rating for the cable at high temperatures was added because there was feedback that happened quite a bit. A similar thing I know also happens with the high power PSUs, that they can also overheat and cause deration. Was it also considered to add that one, or is it under a different error code?
So that would, so the way it's defined right now is that would fall under the high temperature within the EVSE code. We have not had recommendations to put this or split this up into derate and stop, because this particular high temperature could be from different components on the EVSE. Like manufacturers could have, it could be in the power modules, elsewhere. But this is very specific to the cable assembly. So this had a little more granularity to be able to tell. So this is, again, this whole process is data driven. So we get enough data to say very specifically from cable over temperature, we've got derating and stop, and it's significant enough that we would like to split that. So that's the reason behind that. But again, like, it is possible to do that same process for several others in here, but we just did not have that amount of data to go off of it. Again, it's a minimum set. Manufacturers are free to go above and beyond, make more detailed codes as follow-up.
Okay, thank you. I will take an online question. Do you distinguish which error codes are specific to DC charging versus AC charging?
Yes. So in this particular case, this effort is very focused on DC charging. A lot of these apply, some of these apply to AC as well, but ChargeX in general is focused on the public charging experience, and more specifically the public fast charging experience. So a lot of these you would see them to be very specific to DC. But when we put out future documents with implementation guides, etc., we will specify if there are some that are only DC or only AC.
Okay. Let's see, we have Sandra Duarte. She is going to ask several questions, but she started with one. Is the MREC list recommended based in customer pains only, or? Yeah. I don't think that is the correct word. Is the MREC list recommended based in customer pains plans only? Not something you can work with as a question.
Sorry, I wasn't clear on what the question was.
Sandra, please rephrase your question. Perhaps we can answer it. Let's see. Got a question from the audience. Oh. Just check one question. Please state your name.
Andre, just looking here in the connector look further, and come from the DSC as well, right? But as you said, you have more focus on the DC, so I suppose that's why you didn't consider the DSC perspective as well.
Hey, Martin, I'm not able to hear very clearly. Is there a possibility you can type the question in chat, or probably get closer to the mic or something.
Hear me now? Hello?
It's a little muffled. I am not able to distinguish the words.
It's strange. Can you hear me better now?
Yeah, it's better now.
I think it's a problem of facility. It's perhaps a battery problem. Can you tell me the question? I will repeat.
Yeah, the question is of connector lock failure.
You're not too fast. You're Spanish, I think. Well, maybe you can join us here in front so you can see you as well. It's the end of the day. I think the batteries are low. So here we go.
Can you hear me now?
Oh yes, much better.
Okay, great. And the question is about the connector lock failure, as I see that is not listed as a responsibility in EVSE, but it can also be on the, so it's the number one, also be for AC, it can be a problem. So this actually entitles two questions. One is about why is not responsibility here for the EVSE, and second, being one, I guess there has to be a distinguished error code, or if it's from the EVSE side or from the EV side.
Yeah, so again, that comes down to the definitions. More specifically, in this particular document, we define that as a failure to lock or unlock connector on the vehicle side. Because in the US market, we are looking at devices that are mostly, that have, they're not the two-sided lock connectors like you see, and they are, there is a connector lock failure on the vehicle side for the most part.
Okay, thank you.
And yeah, it comes down to definitions, which is why we're like some of these are familiar from OCPP 1.6, but they're not, they don't mean the exact same thing. And which is why if you're going to use this particular set, we want you to specify in the vendor ID that you're using the ChargeX set, or you're using OCPP 1.6 or EVgo, or anyone else that has a specific set that they want to get to. So.
Okay, I think I've enhanced the audio. Do you hear us better now?
Yes, much better, Martin.
Yeah, I think it was a setup problem. Okay, this works. Let's see. We have another one. Would you also be able to distinguish which faults are only available locally? For example, no internet could be implemented as a last gasp message and on-screen indicator only. There's a question by David Coates.
Yes. So again, that is up to the individual CSOs to deal with. We've included no internet, even though this cannot be transmitted back via OCPP at the very moment when there is no internet, because obviously no connectivity. But this could be something that is transmitted potentially after connectivity is restored, or this could be something that indicates to the user that, hey, this particular EVSE does not have internet connection, so probably try a different station or different charger. And so that there are multiple ways that can be implemented. So short answer is we're not specifying that you need to do it a certain way, but some of these are clear and obvious that they cannot be sent over right away, and then you just display those on the screen or send a message to the vehicle or the user somehow in whichever fashion you would like.
Okay, thank you. Another question? No? Okay, then I would like to thank you, Benny, for getting up this early, very early, at your part of the world.
Yeah, thanks everyone. This is our typical working time, so we start work at 7:30, so it wasn't too early.
Yeah, we are in Europe, so it's almost 4. Okay, thank you, and I will end this session. And perhaps if you're interested, in half an hour we will have our final session with Lonneke Driesen about the Open Charge Alliance. So everybody join us, also online, and I will end this session. Thank you, Benny, and have a nice day.
Bye.